Welcome to another video. In this video, I will show you how powerful calculus, at least one variable calculus to describe physics, especially in kinematics, but can be extended to dynamics on another physics region. So first of all, what is calculus itself? Okay, I will explain. In among histories, calculus is about rate of change that including I will add this time because it's not about rate of change, which is about the function, geometry, I'm sorry, geometry, and etc. Notice that the rate of change is focused on um, very, very small, yeah, rate of change, of course, that usually we denote this thing as infinitesimals, which this infinitesimals is related or associated to many concepts of physics. First, let's start with limit. So what is limit itself? Consider a function of x which is equals to x squared minus 1 divided by x minus 1. So at this moment, what value of f of x when x, I will have another pen approaching, I will this add this sign as usual to 1. Denote that limit as this, which is mean f of x limit x to a of f of x, which is x approaching to, I'm sorry, I will give some space here. Okay, uh, x approach to a as this, which is a notation for a limit. Um, yeah, I will just copy this function to another place. Okay, I will add so I will add limit x to 1, some value a which is 1. uh a is some value. Okay, I will have some little space here, little bit, no, okay, I will copy this to like this. Okay, next one, limit of x approaching 1 of this function can be written as this, okay, by quadratic. So we can cancel out this because it's not 0, okay, it's only approaching to 0. Of course, we can rewrite this as approximately 1.000 and 1 because it's very, very small but not 0. We use very, very, very small rate of change, which is infinitesimal related about rate of change of very, very small, just like before. And this thing is about division as usual, which is because it's non-zero, so that limit x approach 1 of this function become this, and it's equals or approach to 2. Yeah, you can just graph this at decimals or anything, and you get that this point is has value 2, but by limits, not by just substitute it to the function. Next, notice that limit x approach a of f of x is approximately f of a after removing some bad guys. So that means limit is about approaching variable of a function to some value which its limit will equal to function with respect to approaching value of a variable itself. Yeah, after modification as before. Okay, next, recall that in previous video, velocity v vector in one dimension is defined generally in maybe non one dimension as this. Yeah, displacement divided by time interval between displacement, or rewrite as this. Yeah, it means that vector is now function of t1 and t2, just like this. Now, the problem is in real life, okay, velocity may be or may different by magnitude and its direction for non one dimension. So, how do we calculate the velocity itself, which is have different in time? To answer this question, let t2 become t1 plus h, which is h is this some kind displacement of time, some kind. So I will add this time too. Or we just call it some kind of time shift, or yeah, anything else. Next, I will define t1 as t, which means t is now is instantaneous time, or we just call it right now time, some kind of right now time. Okay, so now velocity is a function of t is for non one dimension. Okay, I just put that as a function of vector is rt plus h minus rt divided by h, which is in note that it can be extended to higher dimension of vector. For now, I will just take it easy for 1D, which is velocity is now just a scalar or just a number. We get that velocity by velocity definition as before, we get this. And next, I will choose h as small as possible. That means now I will have infinitesimal change or just infinitesimal using limit as h equals to 0. So that h equals to 0, and this is the velocity at instant time, which is a definition of derivative, usually denoted as this, known as Leibniz notation for derivative. For now, I will give you a disclaimer with this long paragraph. This method is powerful, which if you have RT or vector RT, you can determine its velocity or its vector as instantaneous velocity, AT or A vector T as instantaneous acceleration, and so on for related to those wages as displacement, as distance, etc. Higher order derivative of times, you can get it by derivative. Now, the problem is if we have v or v vector, how about displacement? R2 minus R1, or its vector form as this RT2 minus RT1. Yeah, just like this. By intuition and definition of velocity, we know that R2 minus R1 in one dimension, I will choose for one dimension, equals to R2 minus R1, RT1, which is the same as velocity itself, T2 minus T1 in one dimension, okay, which I choose T2 is greater than T1, which is the velocity is velocity at those two times. Now, for maybe not constant velocity and using concept of infinitesimal, we can get that RT1 plus h minus RT1 is equals to velocity v T1 multiplied by h. Okay, using a same concept as before, which now I choose h its approach to zero, which has same definition as limit. Next, we add h again, which is now rt1 plus 2h minus rt1 plus h, which is now equal to velocity t1 plus h multiplied by h, and so on and so on, so on, so on, until we get rt2 as final position minus rt1 plus some related by h equal to velocity t1 plus related by h again as multiplied by h as before. Now we can just adding everything, so in the final result we can just cancel this and cancel this out. At the end we can get, or for left hand side as rt2 minus rt1, which is the total displacement, and on the right hand side we get vt1 multiplied by h, vt1 plus h again multiplied by 8, and so on, so on, so on, so on. Next, we define that h is equals to t2 minus t1 divided by some number, which is it's a partition for time interval, so we call it time partition, or just a partition which is about slicing at interval, or in this context it's time interval. So that means if h approach to 0, then n must be approach infinity. Or we know that this is a concept of some largest number, which is its opposite. But yeah, it's about a big, very big, or etc. Then we can rewrite this as sum, sigma as a sum. Sorry, I forgot the limit. Limit n to approach to infinity, sum from k equals to 0 to n, which is now inside the summation velocity t1 plus k multiplied by sorry multiplied by t2 minus t1 divided by n. Now the velocity multiplied by t2 minus t1 divided by n. If this is limit applied, it will create the more accurate distance. Usually this limit, and this is summation of course, is called Riemann summation, or I just call it Riemann sum for short. This Riemann sum usually denote by S, a big S, as sum of all intervals between t1 and t2, and then a function of dt, a definition for definite integral. Now, why I called it definite? Okay, the S itself is integral, but why I call it definite? Because there is another which is called indefinite integral. We have lower and upper and definite, but in indefinite integral we have not. So what's different result? In result, for indefinite we just rt plus some constant of integration c, but in indefinite sorry, that's for indefinite, but for definite integral they are like this as before, and this is extend to factor or higher dimensional factor. Notice that this integral is inverse like of derivative, or we usually known as antiderivative. Proof is for you. There are many things about it, but for now, I would not explain in detail about it. At least you guys have some intuition to understand physics at this moment by its mathematics tools. I think that's it. See you later.